same angle. Because when we make an X shape, if you think about it, if you move that X, the ones vertically opposite each other are always equal. So these type of angles are called vertically opposite angles. If they make an X shape, this angle and this angle will be the same, and then therefore this angle over here and this angle over here will also be the same. Well, any x, if this angle is, let's say, 100 degrees, then this angle is also 100 degrees, which means we also know that this angle is what? 100 degrees. No. This angle would be 80 degrees because that's a straight line. And they all add up to 360, so this is also 80 degrees. It's an example. Shia.
But if it's a perfect x?
Not a perfect x, if it makes an x shape.
But could it make a perfect x?
Well, then everything would be 90, yes. Everything would be 90, yes. Perfectly symmetrical, yes.
That's impossible. Oh.
Yes, no, it's not.
Wait, then it's not x. It's just a plus is a plus.
Okay, it doesn't have to be, yes, it doesn't have to be orientated like this. You can have that same thing just turn it around a little bit, and it still has 90 degrees, yeah. Okay, so that's something called vertically opposite angles. They are equal. If they're vertically opposite, they are equal. They make this X shape, so this and this would be the same. Okay. We also dealt or looked briefly at when two lines, maybe you remember this, two lines meet each other perfectly at that right angle. What are those two lines called? That's a 90-degree angle, that's a 90-degree angle. These two lines are called something. No, these, not angle, we're talking about the lines now. They do add to 180 degrees. These two, perpendicular. So perpendicular lines meet perfectly at 90 degrees. Perpendicular lines meet perfectly at 90 degrees. So that's like if you have a plus sign, they are perpendicular lines, they meet perfectly at 90 degrees. What are two lines that never meet called then?
Parallel.
Parallel lines, yes. So if we have two lines that never meet, they are called parallel lines. They have the same gradient, or they're lines that never meet. Okay? Now, Akira, you okay? Thank you. So, when we draw two parallel lines, such as that, these two lines are parallel, and we put a line through them, any line through them, like this, we now have created a bunch of angles that have relationships with each other. So we've created 1, 2, 3, 4, 5, 6, 7, 8 new angles out of this. Just drawing a line through two parallel lines. So I'll do that again. If I have two parallel lines and I draw any line through them, I create 8 angles. There's a line or a name for that line. That line, it's in the title for today, is called a transversal. Transversal line. It goes through two. Schlock, do you have to turn around so much? Is that possible for you to face this way? Yeah, good. Okay. So with that transversal line, there are certain names to the angles that have been created in pairs. The first name we're going to look at is something called a corresponding angle. So for corresponding angles, you think that I've set up a set of 4 here, and I have a set of 4 down here, and there's ones that directly correspond to each other, that would be equal. I'll give you an example. Angle 4 and angle 8. So this is an angle symbol I'm writing here. Angle 4 and angle 8 are corresponding. Why are they corresponding? Well, they correspond to the same position in the set of 4. This one's bottom right, and this one's bottom right. So I'm looking at this one and this one, the bottom right of the set of 4 on top, and the bottom right of the set of 4 on the bottom. They correspond to the same position. So they're corresponding angles. Anyone give me another pair that might correspond? Destin? 6 and 2, yeah, another one. Anybody else? Shia?
1 and 5.
Very good. 1 and 5 and 3 and 7 are all corresponding angles. And they will, because they're the exact same, they will be equal. They are equal in measure. Okay. Some people like to remember with a letter. So like I have an X here for remembering vertically opposite angles. The letter some people use for corresponding is the letter F, because it kind of looks like a transversal through 2 parallel lines. And if you want to use F to remember that, you don't have to. That's just a little trick. So there will come a stage in the geometry exam where I draw this for you and I say name 2 corresponding angles, name 2 vertically opposite angles. Name 2 vertically opposite angles from this. Akira? 1 and 4, yes. 2 and 3, 5 and 8, 6 and 7. So you'll have to name a pair that make the X shape and are directly across from each other in an X shape. So 5 and 8 make this X shape here, and they're directly opposite each other. There's 2 more types of angles that are created in this. So we've vertically opposite, we've corresponding, and we have alternate. Alternate. There are straight angles, yeah, but new angles. Alternate angles. So an example of alternate, I'll show you what they are first. An example, a 6 here and 3 would be alternate angles. 6 and 3. So now it's a little bit, why have they got a special relationship? Why do you think? Shia? They are equal to each other, is that what you're saying? Yeah. So they would be equal to each other. Anyone tell me why? Why? Destin?
6 and 2 are the same, so 3 and...
Well done, yeah. So 6 and 2 are the same. They correspond to the same position. And then 2 and 3 then must be the same because they're vertically opposite. So 6 and 2 are the same. 2 and 3 must be the same. So my example here are from this diagram are angle 6 and angle 3. They're alternate angles. They're on opposite sides of the line, but they're still equal. So this is a transversal. This is on the right-hand side. This is on the left-hand side. Opposite sides of the line. Not in the same position, but they are also equal. Some people think of this with the letter Z. So the angles inside the letter Z form alternate angles, and they are equal as well. Can anyone give me another pair of alternate angles from this diagram that would be equal on opposite sides of the line? Shia? No? Give up, Destin? 4 and 5, yes. So 4 and 5 are alternate. These are called actually interior alternate. There are some exterior alternate, one's outside. So interior or inside the 2 lines, exterior outside the 2 lines. Anyone give me an exterior alternate? Yeah, 1 and 8 and 2 and 7. So they're other sides of the line and they're outside. So interior, exterior, interior, inside these 2. So this is the interior angles are 3, 4, 5, and 6. They're interior, and then exterior is either side of that. So 1, 2, 7, or 8 are exterior. Now, the next one used is one of those words, and it is co-interior angles. Co-interior angles. And an example of this is not 6 and 3, it's now 6 and 4. Angle 6 and angle 4 have a special relationship, and it's not that they are equal. Can anyone tell me what that might be? So we're looking at angle 4 here and angle 6. They have a relationship together. What do we think it is? Schlock? They're both inside, yes, so co-interior, yeah. They are unequal, but they also have a special relationship. Destin? Very good. They add up to 180. Can you tell me why?
Because they're like 6
Yeah, we're back to this thing. 6 matches 2. We know that. 6 matches 2. So if this is the same as 6, then 6 and 4 form a straight line. And if they form a straight line, that adds to 180. 6 and 2 are the same because they correspond. They have to be the same because this line doesn't change direction. And 2 and 4 add to 180, so now 6 and 4 add to 180.
Why does 2 and 4 add to 180?
Because it's a straight line. Anything that's a straight line that's cut in 2 will add. So if this is 60, this is 120 because it's a straight line, half of a circle. 180 degrees. So if 2 is 60 here, 4 has to be 120 because here's a straight line. Turn your head. It's a straight line. There's a bunch of straight lines here. There's a bunch of angles that add up to 180 degrees.
7 and 5.
2 and 4 are not co-interior. 6 and 4 are co-interior. They're on the inside. So the other set of co-interior are which two?
5 and 3.
5 and 3, yes. They're co-interior on the other side. Okay? So they're not equal, but they do add to 180 degrees because they form a straight line. Letters, I've started with the letters, so I'll continue. C, some people use a C to think of co-interior than the same side inside the lines. There's also co-exterior. 2 and 8 would be co-exterior. They would also add for the same reason, because 2 would slot in here with 6, and 2 and 8 then would be a straight line. Ridley. Yeah. Go. All right. Okay, so therefore, if you know one angle in the transversal here, you know all of them. Yeah, if you know one, you know all of them. So I'm going to draw a different pair of parallel lines. I'm going to put in a different transversal, and I'm going to say that this is 40 degrees. That one's 40 degrees. Do we know all? Yeah, so this one's 40. This one's 140 because that's straight lines. This one's opposite this one, so that's 140. And all of these angles correspond to all of these angles because this line is straight. So this is also 40 because they correspond. This is also 40 because that's opposite. These two are 140. Well, these two are co-interior. You could use that. And this is 140. So once you know one, you know them all. Well, that's the thing. Once you know one, you know them all. Once you figure out one. So some people use to measure an angle. Some people use a protractor to measure an angle. So if you have a protractor, I should have had one to hand. So if we have a protractor, some people use these to measure angles. You won't need to do this in the exam, but I think one of the MyMaths tasks you do. You set the protractor where?
On the line.
You put it perfectly in the middle here. So if you have your protractor, you want the line, the middle of it to be here, and then you measure the angle off this scale. You measure around to here. You don't have to do that in the test. You won't need a protractor for the test. There is a MyMaths task where you do this digitally. Okay, so yes. I think we're looking at